Hello folks. Today I'm going to show how to properly separate a mixture as if we were doing this in a proper lab. The first thing we need is a separatory funnel. You can see the stopcock is missing. I need to put together the various parts to assemble that. So we have the stopcock, Teflon. We have essentially a washer that's going to go between the glass part and the tightener. We have the nut that is going to tighten that. We have an O-ring, that's going to go between the washer and the. So the first step is I'm going to assemble. Push my stopcock in. Place on the washer. You'll notice that this is it's not perfectly round, so there's a specific way this needs to fit in, because if you notice on here, this is not perfectly round, so it fits on snugly. As you can see here, we slide on our O-ring, and then we tighten our nut. It needs to be only hand tight. Is tightened. Okay, there we go. This should move semi-smoothly, but with some little bit of give to it. So remember, closed, open, closed, open. First thing we want to make sure this is closed. Otherwise, we're going to have some problems. Now, see that this is a conical shape, widest around here, very narrow down here. We want to make sure we have a stopper that's going to fit tightly over here. Because when we swirl this, we don't want it spilling out the top. So we're going to seat this in here. So this is not exactly the best one for this, but it fits nicely. And I'm going to put a Erlenmeyer flask under there. Before I go any further, I'm going to label my flask. We're going to have a top layer and a bottom layer. Now, technically, we're usually going to have an aqueous layer and an organic layer, but in case we were able to mislabel them or misidentify them, you might end up throwing out the wrong layers. So if you misidentify the density, so it's best just to go bottom layer, bottom layer. If you think this is going to be the organic layer, go ahead and label it organic. But if you think it's going to be the aqueous layer, label it aqueous. So we're going to place that under there so that no matter what, we have that when we add our sample, we're not going to spill it and lose any sample. Top layer. So I've labeled that top layer, so I know the top layer is going to go in there, and I can identify which layer is which. The next step is to carefully add our sample to there. I'm going to add a funnel up top so that we're less likely to spill, because my organic sample here, we don't want to lose any of this. Any sample lost means you've essentially wasted some product, and we're going to try to minimize the waste and maximize my extraction. So I'm going to carefully pour that in. As long as that stopcock is sealed, you're good. Now, you'll notice I have a little bit of green left. I'm going to add a little bit more of my solvent to try to rinse it out. My solvent in this case is isopropyl alcohol, or rubbing alcohol. So I'm going to try to dissolve a little bit of this. So we're going to extract all of my sample from this flask into here. We're going to try to get as much as humanly possible. If we were being a little bit more tedious, we'd maybe do that extraction again. But since we're just using green dye, we don't need to be perfectionists. Now the next step is we're gonna add our extracting solution. In this case, this is going to be a basic water solution. It's alkaline water, about 3 molar sodium hydroxide. Normally, water is very miscible with isopropyl alcohol. However, basic water is not really miscible. Around 2.5 molar, the miscibility goes way down. So we're going to get 2 separate layers. So I'm measuring out about 10 mils of my base. I'm gonna, if I wanted to be very special, I might do more, or I might do multiple extractions, but we're only going to do one extraction. So pouring this in. Okay. So some things are already starting to happen. Take off that is done. I'm going to seat in my stopper. Now the next part is where we can be a little bit. So I'm going to take this, holding this up, holding the stopper, I'm turning it upside down and swirling. I'm swirling. Now, making sure this is not pointed anywhere near me or anyone else, I'm going to open the stopcock and release any pressure, because the isopropyl alcohol or any other organic liquid will build up some vapor pressure that will need to be released. So as I keep swirling, every so often, I will want to vent it. Sometimes when the pressure builds up too great, you physically hear that, and some liquid will shoot into here, which is why we want to make sure we're not pointing at anyone in particular. Let the liquid drain back down into here before resealing. So I'm keep on swirling. The idea here is that if these 2 layers are not normally able to mix, by swirling this, I'm able to make sure we get maximum mixing between these 2 layers. So I think I'm about done. So I'm going to reseat this back into here. And as you'll be able to see, we are quickly developing 2 layers. The layers will separate. You have a brilliant blue layer up top, and we have our green layer down below. Now, if I made this even more basic, which would make it even more dangerous, I could get a very sharp blue, and the green would become completely yellow, because green dye is actually made out of 2 separate dyes, a blue dye and a yellow dye. What we're seeing here is a separation of those 2 dyes, as one is going into the aqueous layer and one is going into the organic layer. Now, before I go any further, I need to unstopper that, because if I want to drain this, I'm going to want to be able to be sure that we don't have a pressure buildup, because as this drains out, we're going to create a vacuum in there. So I'm going to drain out the majority of this bottom layer. I think we have, as you can see right there, we have a nice separation where you can see, oh, here's a blue layer, here's a green layer, a greenish yellow layer. So I'm going to start to drain this. Turn this up. Doesn't have to go fast. In fact, we don't want it to necessarily go fast. But once most of it's drained, we're going to stop, swirl it, and make sure we get all of the green. Oh. So you can see there's green stuck right in there. I'm going to try to, if we need to, We might even take a stirring rod and knock any droplets down. But we're going to try to get any of this back to any of the layer droplets that are maybe stuck up top down to the bottom. So let the layers reform. If you don't let the layers reform, you're going to have a little bit of problem. Now, one thing we have to be careful of is certain solutions will create emulsions. It's like when you get the drop oil in water, if you mix it up well enough, you get these droplets of oil that become suspended in water. And they become hard to get a proper separation when you have emulsion like that. So we're not going to want to shake too violently as we mix these guys together. So, want to make sure we got a nice firm separation. Now, here's very careful. We got to drain this. My goal is to drain this so the blue layer has just started into the stopcock, and that's when I'm going to stop it. Not there. Ooh. I think that might be it. So we've lost a little bit of the blue layer into there, but none of the blue layer made it into our bottom layer flask. So, with that in mind, I'm going to With that in mind, I have my top layer flask. I have all of my blue layer, in there, all my, let's make sure, all my green layer in there, or just about thereabouts. So rather than drain it through here, and risk remixing, I'm going to pour my blue layer out through the top. Now the sample can be one of these could be re-extracted. If we know, here's my organic layer, I can re-extract the organic layer with another basic solution of aqueous, or I can simply stop right there. So I have a top layer and a bottom layer. You notice we got a nice blue dye over here and a nice green dye over there. Over time, these will degrade because the base does interesting stuff to the dye molecules, but for now we have green and blue. Now the last thing to make sure is we do not dispose of these until you know what one you want to keep. In a situation like this, where we're not keeping either of them, but you would want to test and make sure, does this have the product I want, or does this have the product I want? And by checking that, we can thus find out. So, oh, there's my product. That doesn't have my product. I throw that away. I keep that. So ideally, we've separated this and made a good separation. Now the last thing I want you to do is dispose of this. So I'm going to have some acid in this waste beaker. This waste beaker, a little bit of vinegar, nothing more, nothing less. And we're going to pour our samples into there. The idea is that we're neutralizing the majority of the acid, or of the base, prior to disposing of this. And that's our key. We want to make sure that our base is neutralized before it goes down the drain. You can already see some of the green dye turning a little bit pink. And then we're going to rinse everything and take apart our separatory funnel. It's everything into the waste. I'm rinsing that with deionized water. Let that drain. Rinsing that, letting that drain. And then I'm going to disassemble that. So remember, so it can dry better. So we're going to take off the nut, take off the O-ring, take off the washer, take off the stopcock, and put those aside to dry. I'm going to rinse all of our other glassware, and that will be how we'll finish up this lab. A little bit of dye is remaining behind, so all the more important to rinse. And that is our separation, a mixture lab. That won't be too bad.